The broadcast is now starting. All attendees are in listen-only mode.
Hey there, folks. Oh, how's your guys' December? Pandemic Day 8005. So, just gonna get this show started here. Gotta find the record button.
Awesome. So I did not get any presenter mode or something.
Well, you're set up as an organizer.
Okay. Let me minimize this really quick. And then let me put this slide. You are able to see my screen, right?
Yep, I can see it. Should be good to go.
Awesome. Yeah, thank you. Good evening, everyone. Thank you so much for taking your valuable time for attending this session today. Thank you so much, Adam, for giving me the second opportunity to speak for your user group. It's always an honor. So what I'm going to discuss today. So today we are going to deep dive into the statistics, decoding the statistics in SQL Server. So let's get started. A little bit about me. I'm a database administrator having 7 years of experience in managing SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University. I blog for dbanuggets.com. That's my website. And you can contact me on Twitter at dbanuggets. That's my user ID. And down below, that's my email address. If you have any questions regarding this session, I'm very active on Twitter, so you can contact me on Twitter. So what are we going to discuss in this session today? We are going to see what are the statistics, how to view statistics, what happens when they are not accurate, what happens when they go wrong, and how to update these statistics, and why it is so important to keep these statistics up to date. So statistics, what is it all about, right? Statistics are the blob structures which are saved inside the system tables to describe the distribution of the data inside a column or set of columns or an indexed view. So basically, the query optimizer will use and trust these statistics to determine how many rows that are going to come out of a table, which is also known as cardinality estimates. So based upon these estimates, the optimizer has to go ahead and choose whether it have to do the clustered index scan or seek, or how much memory grant that it have to provide for the query to be executed. And also, because of this reason, the accurate the estimates are, it will help the optimizer to eventually generate the good enough plan to store in that plan cache. So why should we care about these statistics, right? For example, if our statistics are not so accurate and if they are way too like, there is so much difference between the estimates as well as the actuals. For example, if the optimizer think there are only 100 rows that are coming out of a table instead of the actual million rows that are actually coming out of the table, then that will cause that will eventually, those wrong estimates will eventually cause the inefficient plan to be generated inside the for that particular query, and the inefficient plan will be eventually stored in the plan cache, and the eventual executions that we use and run for that particular query, that query will now use the non-optimal plan, so which will eventually cause the slow query response time, right? And also, because of these wrong estimates, it can be way above our actuals or way below our actuals, right? Like in that scenario, it will cause the excessive resource utilization, like high CPU, memory, IO. And if our estimates are way below the actuals, like if optimizer thinks only 1,000 rows are coming out of the table instead of the million rows, then that means the memory grants are based upon those estimates. Then the memory grant for that particular query is only allocated for that 1,000 rows, but in actual 1 million rows are coming out of the table, right? In that case, only small amount of memory grant is allocated to that particular query. But in actual, when the query goes to the execution phase, then the optimizer doesn't know what to do. Now it needs more memory for its sorts. So it have to eventually spill to disk. But what if reverse will happen, right? What if the estimates are too above than the actuals? What if the estimates are like 1.5 million when in actual only 100 rows are coming out of the table? In that case, the memory grants, we are wasting the memory grants, right? Because now the optimizer will get the memory grant for that query, which is way beyond that than it needs. Like it will get the memory grants based upon those 1.5 million rows. So we are wasting the memory here. And memory, we know that it is limited to the SQL Server, right? So that means we are actually affecting the concurrency. And there are many other queries that are waiting for the memory grants, right? So we are eventually affecting the other queries too, and we are reducing the throughput and concurrency. So that's the reason it is so important that our statistics are up to date and near to the actuals, so that they get the good enough, like the memory grants required for that particular query, not more, not less. And it will create the efficient plan to be stored inside the plan cache, and that will be good for the performance of the queries. So how the SQL optimizer will use these statistics? SQL optimizer will use and trust the statistics to determine whether it have to go and do the clustered index scan or seek, or what kind of index it have to use, clustered index or non-clustered index, or what kind of lookups, whether it needs any lookups that are needed, or what kind of join it have to do, whether it have to do a hash join, nested loop, merge join, or whether it have to go serial or parallel, or whether it have to do the batch or row execution mode. All these operations inside the execution plans, all these downstream operations are based upon these statistics. So the accurate the statistics are, these operators inside our execution plan will be correct, and eventually the plan will be the good enough plan that will be saved inside the plan cache. But in reverse, if the statistics are really stale and they are out of date, then these eventual operations inside the plan cache might be non-optimal, causing the non-optimal plan to be saved inside the plan cache. So what could go wrong, right? From the whenever we execute any query, like what happens behind the scenes? Let's start from there, right? From the basics. Like whenever a query is sent to the SQL Server, first what happens is the query that we are sending will be first parsed. That means the query will be checked on its syntactical, if there are any syntactical error, and then a hash is put on that query that we are sending, and that hash is compared to the hash of the execution plan inside the plan cache. If it finds the exact match of the execution plan, then it will go ahead and use the same execution plan for its execution phase. But what if it didn't find any execution plan, right, for that particular query? It will go ahead and build the initial logical tree for the first time for that particular query. And then the query will be now sent to the transformation component. Once a query gets to the transformation phase, almost all the transformation rules are unlocked here. And at certain point of time, many query trees are generated for that particular query. And on each of the query tree that got generated, the cardinality estimates has to be checked on them. Once the cardinality estimates are gathered on each of those query trees, the cost will be checked now on those equivalent query trees. The lowest cost query tree will be the winner, and that particular execution plan will be now saved inside the plan cache. Once that particular query goes to the execution phase, That plan, which is already saved inside the plan cache, will be used for the execution. But before going into the execution phase, the memory grant, based upon those cardinality estimates, will be allocated for that particular query for the execution, right? And then the query will be now using those memory grants to the execution. Whenever it goes to the runtime, it will use those memory grants to do its hashes and sorts. But what could go wrong here, right? This is the regular process. What if these cardinality estimates completely goes wrong? For example, if the optimizer think only like a couple of rows, like 500 rows coming out of the table, but in fact, when the query goes to the runtime, it will give us like 2 million rows, right? That means the cardinality estimates are way too off and they are out of date, right? In that particular scenario, those equivalent query trees that got generated will also be wrong based upon these cardinality estimates, wrong cardinality estimates. And on each of those query trees that got generated, the cost will be also suspect here, right? The cost will be also wrong, and now eventually causing the non-optimal plan to be saved inside the plan cache. And when that query will actually go to the execution phase, wrong memory grant like will be allocated to that particular query, right? Even before the query goes to the execution phase, these memory grants are allocated to the query based upon the hashes and sorts and based upon the cardinality estimates. So now it just estimates 500 rows instead of 1.5 million rows. So in that particular case, the memory grant will be too low for that particular query to be executed. Now, when that particular query goes to the execution phase, then the optimizer doesn't know what to do for its hashes and sorts because that particular memory which got allocated are based upon only 500 rows and it is way too small. So it have to actually spill to the disk. And this happened only because of this single thing went wrong, right? The cardinality estimates went wrong. So that is the reason why it is so important to keep these statistics up to date so that the optimizer can go ahead and grab the results, the updated statistics information during the execution phase. Now we have talked about the memory grant connections, and we know that they are allocated even before the query goes to the execution phase. But do we know like from where these memory grants come from? Now let's see here how they come, where they come from. There is something known as fixed memory, which is one of the component of memory architecture of SQL Server. Now the memory grant connections are stored inside this fixed memory. Now the fixed memory is known as fixed because it cannot be expanded or shrinked when there is a memory pressure. There is certain amount of memory that is actually allocated to this particular memory, usually less than 1% of the total SQL Server memory. So what happens is from the server side, resource governor will be limiting this particular memory, and memory grant connections are stored in this particular memory. Now, even before the startup of the query execution, these memory grants are allocated to any query based upon two things. Based upon if that particular execution plan, if there is already an execution plan, if there is a hashes and sorts which are already there in that execution plan, based upon that. And the other thing is the cardinality estimates. Based upon those two, these memory grants are allocated. So what happens like, for example, if the estimates are very too low, right? Very too way off, like see the optimizer think only 100 rows are coming out of the table instead of 1 million rows, then in that particular case, the memory grant that is allocated will be only based upon those 100 rows. And when this particular query goes to the execution phase, it doesn't know what to do. The optimizer doesn't know what to do because we cannot dynamically allocate memory during the runtime, right? In that particular scenario, the optimizer have to eventually go and spill to the disk for the sorts. So that will happen when there is like low estimates, right? Based when compared with the actuals. But what if the reverse happens? There is a complete different scenario when the reverse happens. Like for example, more and more queries are requesting for more memory grants than they need actually. Then in that case scenario, what will happen? Like if our estimates are way too above than our actuals, then in that case, that optimizer will be requesting more and more memory, right? But there is this fixed memory which is only allocated to only allocated some part, right? It cannot go ahead and allocate like if queries are requesting more and more memory, it is not free for the SQL server to go ahead and provide them the memory. Then what will happen in that scenario? The fixed memory will get full, right? And the eventual executions of the other queries, they are waiting for this fixed memory because they need some memory for their hashes and sorts, right? In that scenario, what will happen is there is a pressure on the SQL server. There will be the memory leak. There will be so much of pressure because the fixed memory can't be expanded or shrink by itself. So there is an internal pressure, and when this internal pressure occurs, the SQL server has an alert system saying it will know, right, when there is a memory pressure. It will go ahead and request the other memory components to release the memory. Now, what do I mean by that? Like, for example, there are these other caches, right? Like the plan cache, buffer pool. The SQL Server will request, those are the major components of the SQL Server memory architecture, right? Let's take the plan cache in our example. The SQL Server will request the plan cache to evict those execution plans out of it such that it can release some memory and it can use that memory to provide for these queries for their memory grants. That's how it gets managed whenever queries are requesting more and more memory. Many of us might think like, okay, SQL Server will take care of it. It will go ahead and allocate whatever the memory the queries are requesting. But that's not the case. You don't know what to do. Even SQL Server should have to go and request this other memory, which will cause the eviction of these plans out of the plan cache. So whenever this thing is happening, whenever the SQL Server is requesting and all these eviction of the plans are happening, and when this fixed memory is in the block state, right? Whenever this happens, no other operations can be accessing this fixed memory. And also, from the SQL Server side, you can see these resource semaphore waits happening until the memory is actually being released for the fixed memory. So whenever this memory pressure happens, you can also see the in the error log, you can see this memory error message 701. So that is the reason why it is so important to keep our statistics up to date. Now let's talk a little bit about the memory grant feedback, right? Because of these queries, many queries going and spilling to the disk, SQL Server identified that there is an issue that is going on, and it released this memory grant feedback feature in 2017. But when they released for the first time in 2017, this particular memory grant feedback feature was only supporting the batch mode for the column store indexes, especially for the CPU optimization. But in 2019, Microsoft decided to support for the row mode for the hashes and sorts that we use in our query. And this particular memory grant feedback feature is for the compatibility level 150. And there are some, let me describe like what is this memory grant feedback, right? So we have seen in the previous scenarios that the queries has been, the optimizer doesn't know where to do the hashes and sorts, so it have to actually spill to disk, right? In that particular scenario, what the memory grant feedback does is, it will go ahead and check how much memory has been actually spilled to disk, right? How much memory grant that it caused that it was not sufficient, and it will take that memory grant, and for the next execution, it will go ahead and it will release that particular memory for the next execution of that particular query. It will just add to the previous memory of how much the memory has been missing. But in reverse, if the queries are requesting more and more memory, right? Even in that scenario, the memory grant feedback will kick in and see, this particular query is taking more memory. Now, if the memory that this particular query is wasting is more than 50%, then go ahead and reduce the memory for the next execution of the query. That's how the memory grant feedback works. It will go ahead and it will adjust itself based upon that, how much memory does the query needs. I'm not saying that memory grant feedback is a complete replacement. Even without updating the statistics, memory grant feedback is anyway taking care of this. It's taking care of these memory grants, right? Why should we keep the statistics up to date? I'm not saying that, but there is this option where it is useful, like if it actually spilled to disk for the eventual executions, it can adjust itself, but it is not good for all the scenarios, right? I will explain, like, for example, if we have a query that is being executed today with a different parameter, which will give like 1,000 rows in return, right? And after 3 to 4 months, we are executing the same query, like same store procedure with a different parameter, and that will give us the 2 million rows. In that particular scenario, memory grant feedback can be really helpful. It can go ahead and adjust itself, because for the first execution, we got only few rows, and for the second execution, we got million rows, like 2 million rows, right? In that particular scenario, the memory grant feedback can kick in and adjust itself and provide the memory that it needs dynamically in the execution plan. But what if we are very frequently executing a store procedure with varied amount of variables, right? With a different amount of variables very frequently. Then in that case, and if each of these executions have so much of difference in their results, like if one variable can give you 500 rows and if the other variable gives you 5 million rows, then in that case, and if you are running very frequently, then in that case, memory grant feedback will be kick in, but it couldn't decide itself like where it have to get stable, right? How much memory that it have to allocate for that particular query and where to settle. It doesn't understand. So eventually it have to go ahead and turn itself off for that particular query. But it will just go ahead and turn itself off for that particular execution plan. So that's how the memory grant feedback works. And memory grant feedback will be lost when the cached plan is discarded from the cache, like when there is a memory pressure, right? If that plan is evicted out of the cache, then these feedbacks are lost. And whenever there is a memory pressure and changes are not captured in the query store, that is the important point. And whenever there is a failover, then these feedbacks get lost too. And there are like main stages for these this memory grant feedback. Like whenever you see in your execution plan properties, you can find these memory grant feedback options. Mostly you'll see these 4, but you'll also see the others. But the main ones are the first execution, adjusting, stable, and disabled. So whenever you run the query, after you enable the memory grant feedback, for the first few executions, you see first execution, like whenever that gets kicked in, the memory grant feedback, you will see the option first execution. And whenever it is adjusting its memory, but it is not completely adjusted, it will show you the option as adjusting. And once it granted the required memory for that particular execution plan, then it will show you as stable option. And as I discussed before, like when you very frequently run the queries with different variables and you have that wide difference in the results, then in that particular scenario, the memory grant feedback kick itself off, right, for that particular execution plan. At that particular scenario, it will show you as the option disabled. Now I will show you how the memory grant feedback will work in our demo. Now we have discussed enough about the memory grant feedback, but let's start by discussing about the database options we have for the statistics. So whenever you see the properties in the database level, you see 4 options related to the statistics. The first one is auto create statistics, which is by default turned on. And the second option is auto update statistics, which is also enabled by default. Now, I suggest you to keep these enabled without turning them off. There are scenarios when you can turn these off, but most of the time, I suggest you to keep these 2 options turned on. Now, whenever the auto create statistics is turned on, whenever SQL Server think that it needs to create a statistic, it will just go ahead and create a statistics on the background automatically. And with the auto update statistics, whenever SQL Server will find that there is an outdated statistics which is already not valid, it will just go ahead and update the statistics automatically on the background. When you come to the third option is auto update statistics asynchronously. So this particular option I'm going to discuss in detail in the later slides, but this is disabled by default. I will explain you in the later coming slides of when it is suitable to enable this option. The fourth option is auto create incremental statistics. This particular option is especially for the partitioning tables. If you have partitioning, then you can think about it. But if you do not have partitioning, you can just keep it false as it is by default. It is false. Then you can keep it as false. Now there are many ways to create the statistics, right? Now whenever your auto create statistics is turned on, which is by default it is turned on, then SQL Server will go ahead and automatically create the statistics whenever you create a clustered index, non-clustered index, or filtered index, or an indexed view. Whenever you create these, SQL Server on the background, it will go ahead and create the statistics on those particular columns with the exact same name of that particular index. Now let's see an example. Here, I have created a non-clustered index, right, on territory ID column. Whenever I create this non-clustered index, it will go ahead and create the statistics with the exact same name of the index, right? And on the same exact column. Now the statistics got created on territory ID column here. Now the name might be same, right? The statistic name as well as an index name is the exact same, but those two are different entities, right? The index, it will store the data itself, but the statistics will just describe the distribution of the data at the time of the update, right? Now you can view this information, the statistic information, by using sys.stats view. Now statistics also gets created on single columns, like single columns as well as multiple columns. Sorry, it can be created on single columns as well as multiple columns. Now, whenever SQL Server whenever you run a query, that is actually you are searching on particular column or you're joining on a particular column. In that scenario, when your auto create statistics is turned on, then SQL Server will go ahead and create statistics on that particular column whenever you run that particular query for the first time. Like, let me show you an example. Here, I am doing a search on a column named color, right? When I first executed this query, if that particular column is not in the key columns of an index, then SQL Server will go ahead and create the statistics on the background on that particular column color. Now, when you see here the statistics, by running the sys.stats, I can see the statistics name that got created, but it is a system generated, right? By looking at it, we can say it is system generated. The underscore WA represents Washington State. Underscore sys represents the system generated. Underscore 0006 is the column number in the table. And underscore 08B5, that particular number is the hexadecimal value of the object. So that's how the automatically gets created, right, on the particular column. And statistics will also get created when you are joining on a column. Now, in this example, I'm joining on the list price, right? I'm using the list price column. So whenever I run this statement for the first time, then SQL Server will go ahead and automatically create the statistic on that particular list price column. Even this shows the system generated, right? And you can view that information by using sys.stat view. Now, statistics can also be created manually. It can be manually created on multiple columns, on single columns, or also the filtered values in a column. We can also create the statistics by filtering the values in a column. Now, how to view these statistics, right? We can view the statistics by using sys.stats view to list all the statistics we have for a table. But if I wanted to know about the detail about the statistics, like what is there in my statistics and all the information about a particular statistic, you can use the dbcc command, which is dbcc show statistics, which will provide you three different information, right? The header information, density vector, and histogram. Now I am going to discuss in detail how to view the statistics along with the demo, but this is just an overview. And for the latest version of SQL Server, you can use sysdmdb stats properties just to get that header information, and sysdmdb stats histogram just to get the histogram information. But if you wanted to view in detail about the entire statistic, you can use dbcc show statistics command. Now we have had enough slides. So this session is basically demo driven. So let's see the demo. Adam, can you see my screen? Can you please confirm?
Yep, I can see it.
Thank you. So in this demo, first let's see how to view statistics, right? So in this demo, I'm using AdventureWorks 2016 database, but I mentioned in the corner as big at the end of the database because I just added two new tables, sales order header enlarged and sales order detail enlarged by using Jonathan Kehai's script, this script from which he have written for SQLskills.com. So when I refer to these tables, I'll just say sales order header table and sales order detail table, just for my pronunciation to be easier. So let me put the database in the context. And let's see the index, right? The index list and which index we are concentrating more in this demo by using the sp_help index. Now, this shows the index name, index description, and index keys, right? We are mainly focusing on this particular index. So what I did is I just created this particular non-clustered index on this table, and it actually automatically created the statistic on this customer ID column with the exact same name as the index. Now to view the statistics, like I discussed before, we can see that statistic information with sys.stats, which will provide us the table name, and first it will provide the statistics name which is related to the primary key, and then it will give the information like the name of the statistics that got created for the non-clustered indexes, and then the system generated statistics, right? And then you can also see the statistics ID over here. Now in this demo, we are mainly focusing on this particular statistic. It has the same name as non-clustered index, right? And this statistics is got created on the customer ID column. Now you can view the statistics by using sp_help stats. This particular sp_help stats is actually deprecated, but it will give that wonderful information on which column that the statistics got created. So until they completely remove that option, we can still use it. So this one, it will give the statistic name along with that column name that got created on that statistic, right? We are focusing on this particular statistic. Now, to view the statistic, I can use dbcc show statistics, and mentioning the table name as well as the index name, as well as the statistics name. So when I execute this particular query, it should show me the three parts, right? The header part, density vector, and histogram part. Now this is where the histogram, where the optimizer will depend the statistics on, right? It will come and search how much it have to, like it will come and analyze like how many rows does it think it is going to come back out of this particular statistic, right? It will search here. So this is the header information. In the header information, you'll find the name of the statistic. When was the last time that the statistic got updated? It just got updated an hour ago when I restored the database. So this is how many rows that we have in the statistic. And this is how many rows does it got sampled, right? Now, when you see the rows, the number of rows, these are the number of rows that were there the time of the update of this particular statistic. So when you see these rows and the rows sampled, you can see both the same, right? That means this statistic got updated with a full scan. And when you come to the steps, there are 153 steps in this particular statistic. But in SQL Server, the maximum number of steps are 200 with a additional step, which makes 201 step, 201 steps. If you have a nullable column, if you have null values in your column that you created the statistics on. So in this particular demo, the customer ID doesn't have any nullable column. We just have 153 steps. And it will also provide if that particular statistics is filtered. Now this is not filtered, so it will give you the same exact rows as rows sampled. When you come to the density vector part, this one will represent the uniqueness of that particular column. Now, how does this value get calculated? It is calculated by dividing 1 divided by the distinct values in this particular column. That's how it gets calculated. And when you come to the histogram, this is very important part, right? The first column is range high key. Range high key column will represent the values inside the customer ID column. Now, not each and every value is described here. That is the reason why we have the range rows values. But before going into range rows, let's see the equal rows. Now, what this equal row meaning? For example, for the customer ID value of 11,000, we have equal rows having customer ID value of 11,231 rows. For 11,019 customer ID value, we have equal rows of 1309 rows. Now, but what if you are searching on a customer ID value 11,005, right? We do not know how many exact values are there in between, right? So for all the rows that are in between 11,000 and for all the values of customer ID between 11,000 and 11,019, we have total number of rows 3,619. But we do not know how many exact rows are there for just one value of customer ID, like 11,005 in between, right? We cannot say exactly how many rows we have. That is when SQL Server the optimizer will go ahead and get the value from average range rows. But how is this average range row gets calculated, right? There is another row which is distinct range rows. Now, how many distinct values we have for the previous customer ID and the current customer ID? Like how many distinct values we have between 11,000 and 11,019? We have 18 rows, right? And by dividing these two, the range rows divided by the distinct range rows, we get the average range rows. For example, if we are searching on a customer ID value 11,005, which is in between these two, now the optimizer doesn't know how much exact values because we just have equal rows, right? We do not know how many exact rows we have for that 11,005 value. So that's when the optimizer will go ahead and get that value from the average range rows. by dividing the range rows with the distinct range rows. Now to get the same information like DBCC show statistics, but to get the header information part and histogram information part, we can execute these both queries, which will provide us the same information like DBCC show statistics. This is a histogram information and this is a header information. Now let's see an example, right? I'm doing a search, searching on a customer ID where the value is 11,091. Now when you see the histogram, the 11,091 here is unique, right? It is being represented in this particular histogram, and we have equal rows of 2,156, right, of this particular value. Now let's see if that if it gets like the exact match. Sorry, I did not enable my execution plan, actual execution plan. Now I enabled it. Now when I execute that particular query and go to the execution plan, Adam, can you see my highlights? Like my highlight, like my zoom it is not working properly. So I just want to make sure you are seeing my zoom it.
Yeah, I can see it. The purple box.
Yeah.
Yep.
Awesome. So it is actually not working with some of the tools. You know, so I don't know why. For some it is working, so I need to confirm it. Thank you. So the actual number of rows here are 2,156, and the estimates are exactly 2,156. That is 100% match, right? Now, why is that? Because that particular value, 11,096, 11,091 is exactly represented in our histogram. Now let's see with a different value, which is not actually represented in the histogram, 11,225. Now, when you see the DBCC shows statistics, 11,225 is in between these two values, right? So as we discussed, like whenever it couldn't find the exact match, it will go ahead and get that value from the average range rows, which is 263.5. Now let's see whether it will go and get from average range rows. When I execute that particular query, go to the execution plan. Now when you see here, the estimated number of rows are 263.5 and the actual number of rows are 154, right? It is just estimating from the average range rows. Now what if I put that, like I declare a variable and then set that variable and use the variable in the select statement instead of directly declaring the value. Now when I execute that particular query, now when you check here, the estimated number of rows are 126.7. Now actual number of rows are 2,156, but from where is this value coming from, right? 126.7. Let's see. Now whenever you use a variable, the optimizer doesn't know at the pre-optimization stage, right? It doesn't know what that value is whenever you are using the variable. So in that particular scenario, it cannot decide. So the optimizer has to always get that value from the density vector. Now, how does it get that value? Is it will multiply the total number of rows, right? This total number of rows with the density value, density vector value. Now, how much is it if we multiply together? It should give you that 126.7 is the exact value that we have seen, right? In the estimated number of rows. That's how it gets calculated for the variables. Now, what if instead of the equality, I use an inequality here? The same query with an inequality. When I execute that particular query, now did you observe the execution plan is completely changed? The previous one was the clustered, non-clustered index seek and a key lookup. But here, the plan is completely changed. It thought the clustered index scan would be better, right? Now, why it thought like that? Is the estimated number of rows are 726,000, way too above, right? But the actual number of rows are just 19,000. Why is it so different? Let's see. Whenever you are using the greater than or equal inequality symbols, whenever you do that, SQL Server do not know from where to get the estimates. So it will always go and get that by 30%. It will multiply by it will multiply total number of rows by 30%. When you execute that, when you see the results, it is what we have seen in the estimates, right? 726,000. Now, what if I put the same query in a store procedure? Because we all run the store procedure, we don't dynamically run the ad hoc queries, right? Let's put that particular query in the store procedure. Now my store procedure got created. Now when I execute that store procedure for the first time with this particular variable, it will go ahead and create the execution plan, right? It will go ahead and create the execution plan with the index seek and a key lookup. Now this particular value is unique in the statistic. It is actually represented in the statistics. So that's the reason the estimated number of rows are 77 and the actual number of rows are 77. But what if I go ahead and execute the same store procedure with a different variable? Now, when I go ahead and execute with a different variable, now the estimates are still showing 77, right? But the actual number of rows are 2,156. Now, why is it showing 77? Is because when we firstly executed the store procedure with a variable, then it actually the execution plan got created and it got saved inside the plan cache. Now the subsequent runs, which you execute the store procedure with the different variables, then that particular query will use the cache plan, right? Now this will be a problem when there is so much of skew in your data, right? This is just my demo. Like my estimate shows 77 and 2000, that's okay when you compare to estimates and actuals. But in the real-time data, if you have so much of skew in your data, that might be a problem, right? The one variable giving you 500 rows and the other variable giving you 5 million rows, that means that will be creating a problem for you. So it is very crucial to know what plan is getting generated for which variable the plan is getting generated and what plan exact the optimal plan. We have to make sure the optimal plan is getting created and saved inside the plan cache, right? If there is not much skew in the data, if the data is even, that's okay, but we all have skews in our data, right? So it's really important to know what plan is getting saved. Now I'm going ahead and creating another store procedure, but this time I'm not using the customer ID. I'm not declaring customer ID, but I'm declaring something else, some other column, and then declaring the customer ID, and then setting the customer ID and using the customer ID variable, right? Now let me go ahead and create that store procedure. Let me execute that particular store procedure for the first time with a person ID, not the customer ID, but a person ID. When I execute the store procedure, now I see the estimates as 127. Estimated number of rows are 126.7. The actual number of rows are 308, right? Now where is this value coming from? Because we are not declaring the customer ID, right? We are declaring person ID. So the optimizer doesn't know at the compilation time what the customer ID value is. In that scenario, you'd have to actually go and get that value from the density vector. Now, when I go and execute with a different variable, it will go ahead and use the same value, right? There is no difference. It will always go ahead and get that value from the density vector. Now let me not only get the values from the sales order header table, but this time let's join with a different table, sales order detail table, right? Now I wanted to run two statements and doing a search on a order date. First we will do for the 1 month date range. This is 1 month date range, and then the 12-month date range. Let me go ahead and execute both the queries together. And let's see the execution plan for the 1 month as well as the 12 month. Now, why I'm doing this is because I wanted to show for date ranges, right? For the small date range, the execution plan might be different, and for the bigger date range, the execution plan might be completely different. So for the 1 month date range, when you see here, the estimated number of rows, actually, the estimated number of rows are some 4,000. I'm sorry. So the estimated number of rows are 4,600 here, and the actual number of rows are 5,000, right? Pretty close for the 1 month date range. Now, when you see here, it is doing an index seek on sales order detail table. Now, why is it doing index seek is because for the 1 month date range, the optimizer only thought that it is going to come out of the table are 4,600 rows, which is pretty small, right? Pretty small amount. So that's the reason, not only like the values that are coming out of the different table like sales order detail table also dependent upon how many rows that the optimizer think are going to come back out of sales order header table. Now, as only 4,600 rows are coming back out of sales order table, the optimizer thought it can only do this index seek would be better because there are only some rows, right? But when you are seeing the 12-month date range, when you see here, it just got 1,105K here, and the actual number of rows are pretty close, 105K. Now, as the number of rows got increased here, the optimizer thought it would be really better if it can do the clustered index scan, because now the number of rows are too many, right? And also, when you see the downstream, it has taken us to hash match as well as the sort. Now, as this is 12-month date range, this is expected. Now, what if I go ahead and show you row and page count of this particular table? Now we are dealing with this particular customer ID index, right? And how many rows do we have in this particular table? We have 2.4 million rows, right? Now, what if I go ahead and trick the optimizer by saying we just have 1 million rows instead of 2.4 million rows? Now, why I want to do that is because I wanted to show you like what happens to these execution plans and how does it affect the execution plans whenever the optimizer get the wrong estimates, right? To do that, I'm just tricking the optimizer by saying we just have 1 million rows. So I'm going ahead and updating the statistics by saying with row count 1 million. When I run that, it will immediately get affected. Now let me show you. Now, when I execute that particular query one more time, it got updated, right? It got updated with the primary key saying only 1 million rows are there in that particular index. So when I execute that, and when I run this again with 1 month and 12-month date range, let's see the execution plan now, whether it got affected or not. Now it's taking a little bit time. When you see this 1 month date range here, did you see the estimates here? They're off. Like the estimated number of rows are 1,900 right now, and the actual number of rows are 5,000, like we saw previously, right? That's okay for 1 month date range. But for the 12-month date range, if you see here, the estimated number of rows are just 43,000. Previously, we have seen 105K, right? And the actual number of rows are 105,000 here, which is way too off, like more than double, right? Now, it also got affected how many rows that are coming back out of this particular table. Did you see here? The estimates are off even on this particular table, right? The actual number of rows, right? And actual number of rows are 151K. And if you observe here, the hash match and the sort. Now, did you see the sort have an exclamation mark here? And when you hover onto that, you see this warning saying it has actually spilled to disk, right? These many pages, 1500 pages have actually spilled to disk. Now, why is that? Because our estimates are wrong. I tricked the optimizer saying we just have 1 million rows, right? Instead of 2.4 million rows. That doesn't actually only did not affected how many rows that the optimizer think that are going to come out of the particular table, but also it affected how much memory grant that it have to allocate for this particular query to be executed. As we tricked the optimizer by saying there are only 1 million rows, it went ahead and just provided the memory grant based upon those 1 million rows. But in fact, when in real time, like when the query went to the runtime, the optimizer doesn't know where it have to do the sorts, so it had actually spilled the 1500 pages to the disk. And that is the reason why the status keeping updated statistics is really important. And I can immediately clean that by using dbcc update usage. But let me not do that right now because I have even later demos which we are going to see. Let me close that. Let me show you how the memory grant feedback works. Now we are using the AdventureWorks 2016. Okay. And this is a 2019 database, SQL Server 2019 database. So memory grant feedback is automatically turned on. But to show you how the memory grant feedback will work for the previous versions of 2019 and for the later version after 2019, right? For the 2019 database. Let me show you that by disabling the memory grant feedback because this is automatically turned on for 2019 databases. So let me turn off that memory grant feedback. And let me create this store procedure, which is the same query but that we have executed before with the one date ranges, right? I'm putting the same query in the store procedure. And let me go ahead. Now our memory grant feedback is turned off. That means we can think like our query, our database is 2016 or 2014 because it is equal to those databases when the memory grant feedback is turned off, right? It behaves like that. So I'll go ahead and do some executions for the 8 days, 1 day date range, sorry, for the for 1 week date range, sorry, and then for 1 year date range, and then for more than 1 year date range. Let me go ahead and execute that together. I think I did not enable my actual execution plan on. Now, when I go to the execution plans for the 1 month for the week date range, we did not see any much right. We did not see any exclamation mark on the sorts, but when you come below for the 1 year date range, we see an exclamation mark here, right? When you hover onto that, you see this. It has actually spilled 617 pages, right, for 1 year date range. Now let's see for the more than 1 year date range. It has actually spilled 935 pages, right? That is how the older versions of SQL Server works. Like it cannot do anything on the fly, right? Now optimizer doesn't know what to do, cannot allocate memory right on the fly during the runtime. So it has to actually spill to disk for doing its sorts. But this is for the older versions, okay? But what if I go ahead and turn on the memory grant feedback on now? Let me go ahead and turn that on. And let me go ahead and run the same queries, the same date ranges, right? Now the memory grant feedback should definitely be kicked in. Now the 8 days state range. We do not have any issue here. Now you still see the sort here. You still see that it's actually spilling 2 days, but yeah, 638. Now let me go ahead and see the properties of the memory grant feedback. Yeah, memory grant info. No accurate grant. It is not adjusting itself right now. It should take some few more executions to actually pop this. No first execution. We just got enabled, right? We just enabled the memory grant feedback turned on. So it showed me no first execution. So the second time it actually showed me, did it show? So no accurate grant. Okay. Now when you go to the third execution, when you see the properties, did you see here? It says yes, adjusting. Now let me go ahead and show you. Let me also show you here a couple of things. For the third one, let me go here and show you the properties. The memory grant feedback. Now it shows as adjusting, right? So how much memory did it granted? It granted this much of, this is actually KB, 140 KB of memory it granted. And last requested was 4,992 KB. Right? You can see that clearly by hovering over here. Now, did you see here? It says it actually granted the memory here, 4,992, right? So it has actually showed here. So that is how it will add the memory. Sorry, here 140K granted is our granted memory. So it's still adjusting, right? I will go ahead and do some more executions for more than 1 year date range. I'll do the same query. A couple of more times I will run with the same parameters. When I execute that, did I enable the? I think I enabled execution plan. Yeah, actually enabled. So when you see here, it's actually executing. When you check the properties, this time it still had that sort, right? It still had that sort, but when you see here the warning symbol, it just spilled 105. It decreased its number of pages, right? And when you see the properties here, the memory grant feedback, it says yes, it's still adjusting. And now when you see the granted memory is bit high, right? But still it is not sufficient. Still it is spilling to disk, but this time low number of pages. But the next execution, there is no spilling to disk, right? And when you see the properties here, it says yes, adjusting, and it increased the number of KB for the memory. And for the next coming executions, if you see this properties, yes, stable. Did you see that? Now the memory grant feedback that required for this particular query is now stable, and the desired memory was the granted memory was this much. That's how the memory grant feedback will work. Now let me show you how to update the statistics, the third part of our demo. So let me put the database in the context. And now, did you observe like the previous demo, like previous demo, I have tricked the optimizer by saying we just have 1 million rows, right? Now I wanted to update the statistics with the full scan, like 2.4 million rows. Now when I execute that, got executed. Now let me go ahead and see whether it got actually executed. 2.4 million rows. Okay. Now let me go ahead and update my statistics with a sample scan, right? With a default sample. But I did not mention any default sample here because SQL Server will decide that for us. We will just mention update statistics with the table name as well as the statistics name. Let me go ahead and run that. SQL Server will decide itself to update the statistics. And when I go ahead and see my statistics, DBCC shows statistics. Now the row sampled was different, right? Previously it was with full scan, but right now SQL Server decided to do SQL Server. We updated the statistics by using the default sample. So SQL Server decided by itself, and most of the times this default sample should be completely fine if you have large amount of SKUs in your data, and if your system is OLTP, and there are some tables, right, always in our systems that got that will get updated, deleted, all these operations very frequently. In that scenario, doing the full scan is suggestible. But other than that, it should be completely fine to go ahead with the sample scan that the SQL Server decides. Now let me go ahead with the default sample, right, that the SQL Server decided. Let me go ahead and do a particular statement where the customer ID value, and let me execute this and see how we got the execution plans. Did not enable the execution plan. So the index seek and the key lookup, right? In our demo, we have been seeing this. This is normal for these both queries. So with the different parameters we used. So here, the estimated number of rows are 97. Actual number of rows are 154. Now, did you see the little bit different, but they are pretty close, is because the default sample, right? But for the different variable here, even for this, we have a little bit closer, 11,005 and 1300, pretty close. But if you have that, what I mean to say here is, like, depending upon the variables, right? If you have large amount of SKU in your data, then it is always suggestible to do with a full scan. But most of the times in the system, I have seen many clients have been using the default sample. It should be fine. Now, let me go ahead and turn off the auto update stats off. Now, whenever your auto update stats is turned on, like by default, it is turned on, right? Now, I wanted to manually go ahead and turn off because I would what happens when they are off. But whenever the auto update stats is turned on in the database level, whenever SQL Server will find the outdated statistic, like there is a limit, right? The statistics should hit, like in your table, there should be some amount of data that needs to be updated, right? That particular the row count, that it have to actually hit the threshold. There is some threshold that I'm going to show you now. Whenever the updates of your data will hit that particular threshold, then that particular statistics will be outdated. That means it gets invalidated. And the next time when you run the different query that is actually using that outdated statistic, then SQL Server will automatically go ahead and update that particular statistic when your auto update stats is turned on. But right now I'm turning itself off, right? I'm turning it off. So I'm going ahead and updating bunch of records actually. So let me go ahead and show you the threshold detail. It should be somewhere here. Yeah, this is the one. So I wanted to show you the threshold values. When I execute this particular query, we are mainly focusing on this particular customer ID statistic. Did you see here? The old threshold, which is before 2016 servers, right? The number of rows that needs to get updated to invalidate the statistics is 485,000 rows. It is too many, right? But the new threshold is just 49,221 for this particular statistic, just 49,000 rows. which is way too different, right? Because the algorithm is different for them. Now, as our database is 2019 database, let me go ahead and update bunch of records now. But right now my auto update stats is turned off. So when I execute that, it's running, it's updating bunch of data, but it should be more than our threshold. So as it is updating, it will, once it updates, it will actually hit the threshold. So it will actually invalidate my statistics. It will, so 890,000, which is way above our threshold, right? Now I'll go ahead and execute the same, I will go ahead and execute a query that will actually use this outdated statistic. But when I run that, SQL Server won't do anything. It will go ahead and, let me turn this off. Let me enable. It's actually enabled. So when I execute that, it will go ahead, since my auto update stats is turned off, it will go ahead and use the same outdated statistics information. But when your auto update stats is turned on, and when your statistics is actually outdated by so much of data that has been changed and it hit the threshold, and now your statistic got outdated, then when your auto update stats is turned on, SQL Server will go ahead and update the statistics behind the scenes. And once it do that, it will go ahead and invalidate the execution plan also. We'll go ahead and invalidate the execution plan. It will create the execution plan and then use that new execution plan with the updated statistics on it for that query to be run. So while this particular query is running, behind the scenes, all these actions should happen. It should go ahead and update the statistics first, then invalidate the execution plan, create the new execution plan, and then use that execution plan with that updated statistics on it, and then give the results to the user. But now our update stats is turned off, sorry. It will go ahead and use the same old execution plan. And when you hover your mouse over here, the estimated number of rows are just showing 1800. But did you see the actual number of rows? 890K. Now why? Is because our statistics is out of date, and this particular query is going ahead and using the same old outdated statistics. Right? Now what if I go ahead and turn the auto update stats on, right? Now the next time after I turned it on, the next time I go ahead and execute a query that is actually using that outdated statistics, when I execute that particular query, it should go ahead, it will take some time. It will go ahead and update the statistic, outdated statistic, it will update it, invalidate the execution plan, which this query already have, create the new execution plan, and use that execution plan to provide us the results. It will take some time. This won't create any problem generally, but if this is causing a problem for you, right? If your users are waiting to get the results, and if that is causing a problem for you, then you have other options also, which I'm going to discuss in later slides. Now this particular query got executed. Now did you see the query, the execution plan is completely different now, right? Now it got clustered index scan with clustered index scan here, and it thought clustered index scan would be better because there is so much of rows here. The estimated number of rows are 905, okay, and the actual number of rows are 890, which is pretty close, and that difference is because our statistics is actually updating with default scan, right? Now to know whether our statistics are actually got updated, we can go ahead and see in our DVCC show statistics in the results. Now this is the time, right? 7:47 for me. It's just, it happened a minute ago, just got updated, but it still got updated with the default sample. And the statistics got completely updated, like pretty close to the actuals, right? Now let's see how this stats update will affect the stored procedure. Our auto update stats is turned on. Now let's see how this will affect the stored procedure. I'll put the same query in the stored procedure. Let me go ahead and execute that. And let me go ahead and first execute this execution plan with a variable and run that for 10 times, right? Now this is pretty common, like index non-clustered index seek and this key lookup, which we are seeing is okay. And the number of rows and actual number of rows and the estimates are pretty close to 100 and 31 is okay. I think it got executed. Okay. Now let me go ahead and show you the query plan, right? What query plan got generated by running this query. Now this particular execution count is 10 because we executed it 10 times, and plan generation number is 1. One plan got generated, right? And now let me go ahead and show you the old threshold and the new threshold one more time. When I execute that, this is particular customer ID statistics, which we are focusing on. Now the old threshold, which I showed you, and the new threshold, we have to hit 49,000 rows in order for our statistics to be outdated, right? Let me go ahead and execute bunch of update bunch of rows, right? Let me go ahead and do that. It will go ahead and update bunch of rows. It actually updated many rows. Let me go ahead and show you the row count. We can actually see with this row modification counter query, the same query that we have seen. Previously, the row modification counter was 0, but now as we updated bunch of rows, these many rows we got updated, which is way above than our new threshold, right? So now our statistic got outdated. Now, whenever I execute the store procedure for the next time that is actually using that outdated statistic, then it should go ahead and in the same way, it should go ahead and update it will invalidate the execution plan. It will update the statistics and invalidate the execution plan, create a new execution plan, right? So this is what it created a new execution plan. And now if I wanted to see whether it got updated, the statistics got updated. When I see the DBCC shows statistic, now it just got updated, right? But what if I wanted to go and see if our execution plan got created, a new execution plan? When I execute that, previously we executed it for the 10 times, right? Now here, the plan generation number is 2. So the new plan got generated. Now to know if, because the plan can generate, the new plan can get generated because of various reasons, right? It can get invalidated and create new plan. But how to know whether the update stats is actually causing the plan to be invalidated and to generate a new plan? How to know that? We can use the extended events session to know that particular information. So here I'm going ahead and creating an extended event session, which I'm doing on the database ID with a reason saying SQL statement got recompiled, because that's when the execution plan gets recompiled, right? Regenerated. So let me go ahead and create that extended event session. Now this actually exists already. So let me go ahead and start this extended event. So now my extended event got started. Let me go ahead and there should be management. So extended events here, sessions. I wanted to see watch live data. Now let me put this, let me close this. Let me put this aside like that. And let me go ahead. Now my Now my extended event is turned on, right? Now let me go ahead and update bunch of records one more time so that it will actually hit the threshold. Now we have actually hit the threshold. So let me go ahead and see the row modification counter, whether it had actually hit the threshold or not. When I see the results, this is where we are more focused on, right? Yes, it has actually reached the threshold. Now, until I execute the other query, which is actually using that particular outdated statistic, my update stats would kick in, right? So let me go ahead and execute the store procedure one more time. That will actually go ahead and it will recompile the store procedure. Now let me see that. Now, did you see here SP that recompile? That the statement got recompiled, and when you hover over here, like when you come down, the object name is sales order header data, and you can see the statement too here. And what is the reason? There is a reason, says other, and when you come down, stats update. Now this particular stats update has caused this particular store procedure to get recompiled. So that is how we can track it. Let me go ahead and turn off this event session. Let me close this and this. Let me hop back into my slides. I hope, Adam, you're seeing my slides.
Yep.
Thank you. So as we discussed in our demo, there is two thresholds, right? The old and new threshold. Now, if your auto update stats is turned on, then the old threshold before 2016, these databases will, those update stats will occur when your row modification counter has actually hit 20% plus 500 number of rows that should be actually changed for your stats to get outdated, right? But for the new threshold, it is way, way small. Now, how does that get calculated is by square root of 1,000 times number of rows, which is way, way small. Now, if your tables are very volatile, right? If you have those inserts, updates, the OLTP systems where there is so much activity going on your tables, then the new threshold will be really useful to put your statistics up to date, right? Whenever this threshold got hit by your row modification counter, then the stats gets outdated, and the next time you use the query that actually use that outdated statistic, then the SQL Server will just go ahead and update these statistics behind the scenes, right, without your interference. Now, this particular new threshold is for SQL Server 2016 and higher, and also it is enabled by default, and for the compatibility greater than 130. You can also, if you want, you can also use this particular new threshold for the older versions of SQL Server by enabling race flag 2371. Now, there are some points to remember. Whenever your auto updates turn on, whenever your auto update stats is turned on, what we have seen in our demo is whenever our updates has actually reached the threshold, that row modification counter has actually reached the threshold, then whenever our query that is actually using that old statistic, the SQL Server will just go ahead and first update the statistic, and then it will invalidate the plan, right? It will invalidate the plan, generate a new plan, and use that plan. But what if there is no data change, right? In this particular slide, we are going from below to top. So let's talk about the SQL Server 2012 and above, the bottom one. Whenever your auto update stats is turned on for SQL Server 2012 and above, and if your data is not changed, right, then the optimizer thinks there is no use to invalidate the plan because there is no data change, right? So it won't invalidate the plan. But before SQL Server 2012, if your auto update stats is turned off, then regardless of your data change or not, the plans doesn't get invalidated. But before SQL Server 2012, if your auto update stats is turned on, regardless of data change or not, plans gets invalidated. That there are some points to remember. Now, in our previous slides, I have told you that I will be discussing about this option, auto update stats asynchronously option. Like what will happen if we turn on, right? It is by default, it is turned off. Usually, when your auto update stats is turned on, then these, whenever we hit the row modification counter, it will just go ahead and update the stats, right? But there is some problem to it. Like while your query is still running, behind the scenes, the user should wait until those outdated statistics got updated, and then to create the new execution plan even before they get the query results, right? But if that is causing a problem for you, right? If that auto update stats is turned on, whenever those stats are getting updated on the background while the user is waiting, you will actually see this wait type into SQL Server 2019, wait on sync stats refresh. This particular wait type you will see when the stats got updated on the background. But if you think that this is causing a problem, your users are waiting to get their results, then you can turn this auto update stats asynchronously option on. Now, when you turn this option on, whenever the SQL Server will encounter that statistics which is already outdated, it will say like, okay, I know that the stats got outdated, but please hold that stat and not update that, because auto update stats asynchronously option is now on. Let that user who is actually using that statistics right now, let him go ahead and use the same old stats and the same execution plan. Let him use the same execution plan to get the results. Once he get the results, then go ahead and update the stats and invalidate the plan and generate a new plan on the background later. That's how the asynchronous option works. Now, even though your auto update stats is turned on and all these updates are happening on the background, you don't want those auto update stats to kick in during the business day, right? Several times during the business day, or depending upon how much data that is getting updated, like the OLTP systems of how volatile your systems are. Even your auto update stats is turned on, it is really suggestible that you manually maintain these statistics by using the maintenance plans. Like the maintenance plans that we natively have for the SQL Server that you create, we do not have much options in that maintenance plans. But you can use the Ola Helmgren scripts. You have so much of flexibility, like you can change the percentages, and there are several other options to update these statistics specifically. There are specifically two other options while updating the statistics, which you might feel useful. One is no recompute, and the other is persist sample percent. Now, when you use update stats by using this option, no recompute, that means you are saying to the SQL Server that if this particular stats gets outdated, right? Even though the auto update stats is turned on, please do not go ahead and update that particular statistics until I execute this particular query by using update stats with recompute option. Now, why is this option really useful? Because some users doesn't want that particular stats to get updated in the middle of the business day while there is so much of activity going on. So that is that option, no recompute. Now this option, the other option, persist sample percent, whenever you update the stats by mentioning this persist sample percent, usually it will be full scan the 100%. But whenever you mention this persist sample percent, that means you are saying to the SQL Server, no matter if the auto update stats is turned on, please do not use that default sample, right, that the SQL Server decides. But instead, go ahead and use the sample which I am mentioning in this persist sample %. Like usually it will be 100%. Whenever it auto updates, it will go ahead and use the same % you are mentioning here. And this particular option is active from SQL Server 2016 SP1, CU4, and SQL Server 2017 CU1, and for the later versions. So in this statistics session, we have gone through the overview of what are the statistics, how to view them, and what happens when they are not accurate, and how to update these statistics. And we have also gone through the overview of memory grant feedback and when it will be useful. I would like to thank you, Adam, one more time for giving me this wonderful opportunity to present for your user group. Thank you so much.
Yeah, thanks. Thanks for presenting. I was just looking at like a lot of the different features because I haven't followed the 2019 stuff, and it's really cool the different features they're adding to it for helping people to make sure these statistics are efficient and effective. So
Right.
If anybody has any questions, feel free to put them in the questions area. I haven't seen anything that's been posted, so feel free to post those. I'll leave it open for a little bit. We've been kind of coming up with, towards the end of the year here, so it's it's been crazy how time's kind of been flying, and
exactly
how many of these I've set up is just crazy. So oh.
I mean, I have been talking since like 3 months, I think maximum. I have been speaking from August 16th.
Wow.
Yeah. And I already did like around 40.
Oh, wow.
Around 40. It's been crazy. Awesome. Like, yeah, I have been presenting at least like 40 sessions, like including SQL Saturdays and other conferences, international conferences. Yeah, it's been like I'm really loving this.
That's cool. Huh.
Yeah, I've been being very active actually.
Wow. That's been, we were talking before all of this. I was talking to the regional mentor, and I was saying, I was like, that's like one of the positive things that have come out of COVID is the number of just speakers that we've been able to have present to our group that we just normally wouldn't have available to us, that have just been, I haven't had anybody that's been, other than you. I think you were the first person that actually reached out to me and asked if you could present. But we've had at least 3 of them that they've specifically said that they could never come to present to us at like a SQL Saturday. But because of all of this, they've made themselves available, and they were like, yeah, I'll do a remote session. So
how good is that? Yeah. And how I was able to reach out to you is like I literally opened the US graph with all the states, because not each and every state is in my mind. So I literally took the list of the US states, and for each state, I at least registered for at least 2 of the user groups from past website. Like if you see my and I have been once I registered for some websites, I do not have like option to email them. So once I receive that emails, right, the alert email saying that, hey, we are having our next session.
Yeah.
Once I receive the email, I have been sending them replies saying, can I speak my can I speak my, and everyone, the good thing is like people are so good. Yeah. People have been accepting me, like no one said like no Deepthi, like we have these sessions, we are listing out the speakers, like who to speak, like everybody gave me the opportunity. So I have been like almost like some of the weeks were like literally like 7 hours, 7 days, like every single day I was speaking, including SQL Saturday.
Wow. Huh.
Yeah, and some days I had 2 sessions. The maximum is I had 2 sessions a day.
Wow. Man.
And I was speaking even in the middle of the night, like 12 a.m.
Man. Ah,
So I'm really loving this. I'm really loving to learn, persevere, and then share my knowledge. And I'm really liking this. Like I feel really glad. Sometimes I feel guilty that I would have known about SQL family a little bit ago, like few years ago. But I came to know about SQL family during the pandemic time, like right in the peak time.
yeah.
Anything that good happened to me during the pandemic is like knowing SQL family.
Yeah.
Yeah.
It's cool.